Good morning, everyone. So today will be the first online lectures. So the topic today we're going to discuss is the waves and the sound. So we are going to continue our discussion of the wave and sound. But before that, I would like to share verses in the Bible with you. So this is the Psalms 23rd verses 4. Even though I walk through the valley of the shadow of the death, I will fear no evil, for you are with me. So I know that there is an anxiety spread out among our society now, but I just want to let everyone know that we are the Christians and we should have the faith in God and we still have hope. So let's try to put our faith on God and let's help each other try to go through this kind of transition period. So before I start the lecture today, I would like to review the new schedule of the courses today. So I will upload this syllabus on the Moodle soon, but today I want to let you see that the preliminary versions of that. So as you can see from the screen, we still have about 5 weeks left. So this will be the lecture today, and you can see that there's the lab also. But now, as you can already see from my email, the lab will be now running through the simulation instead of the traditional one. So I will produce another video try to instruct you how to conduct the experiments. And please pay particular attention to the homework and the quiz. So for example, we are going to have the first quiz this coming Friday, so be prepared for that. And the instruction how to prepare for the quiz is also listed in the email, so please give a check. And I want to remind you particularly about the exam. So the second midterm exam was postponed to the April 8th, and now the material going to be covered is 4 chapters, not the 3 chapters. So please spend enough time in advance to prepare for the exam. And finally, you can see from the course list here that we already skipped the chapter 27th and the 29th. So it is because that we have 1 week gap. So I try to minimize the course material covered to lower your burden. And for sure, we're still going to have the final exam, and the material going to be covered is the whole chapters we have discussed so far. So now let's go back to the lectures. So today we are going to continue our discussion of the Doppler effect. And then we are going to study that if you have the 2 waves interact with each other, moving in the opposite directions, what will happen? And this is the concept related to the superposition and interference. And standing wave is a very unique example for this. So let's continue. So this is what we have learned in our previous lectures. So it is a Doppler effect due to a moving observer. So for the people who already forgot about the details, please go back and review the lecture 17 for further information. So here I just want to include it, summarize here is that if you have the source fixed, but the observer is moving, then the wavelength will be still the same, but the frequency will be changed. So therefore, this is the relation we are going to have. So f prime is the new frequency observed by the observer, and f is the frequency originally was produced. And we can see that here we have a plus sign and a negative sign. And how should we use that appropriately? So we use the plus sign when the observer is moving toward to the source. So in that case, the frequency will become higher. And if you have a minus sign here, which means the observer is moving away from the source, so frequency will be lower. So this is what we have discussed in the previous lectures. So now, today we are going to continue our discussion of the Doppler effect, but now it is a moving source, but the observer is fixed. So you can see from the diagram here, we have the observers which is stationary, but the source is moving. But now you will find out that in the previous scenario, the wavelength is fixed. But now the wavelength will be changed. So you can see from the diagram here is that there is a source here produce a sound wave, and this sound wave will propagate along the wave speed to the observer, and the wavelength will no longer be the same. So how big the change of the wavelength lambda prime here? So lambda prime is the wavelength, but now the wavelength is the difference of the distance traveled. And since the distance traveled by the wavelength becomes shorter, so the wavelength will become shorter. And here the nu is the velocity of the wave speed, and the u is the source speed. So now in this diagram you can see that the source is approaching to the observer, so which means the distance in between becomes shorter. So that's the reason it is a minus sign. And we know that in our previous discussion that no matter for what kind of wave, the wave velocity is always equivalent to the lambda prime multiplied by the f prime, which is the wavelength multiplied by the frequency. So therefore we can rewrite the f prime, the frequency observed by the observer, which is the velocity of the wave divided by the wavelength, the new wavelength. So the wave speed is still the same because the sound wave was propagated in the air, so this value is fixed. But now the wavelength is no longer the same. So therefore the new frequency will be equivalent to the velocity of the wave speed divided by the difference of the speed multiplied by the original frequency produced by the wave. So as you can see, let's go back to the previous slide. The format is very different. So please remember that in what kind of scenario you are allowed to use what kind of equations. So now let's continue our discussion about the Doppler effect for the moving source. So this is basically the format. I try to rewrite that from the previous discussion, and all the thing I have to do is I simply divided the v in the numerator and the denominators, so I can get this formula. So once again, the previous discussion was based on you have a source moving toward to the observer. So in this case, it will be a minus sign. But if you have a truck which is moving away from the observer, then the wavelength will become longer, then it will become plus sign here. So people normally the first time when they learn that, they will feel confused because the plus and next sign convention is different depending on which one is moving. So please pay particular attention to the difference, which one is moving, the source or the observer. So let's have our first conceptual quiz today. So here is what I will suggest in the future. So when you are watching the video, when you see the conceptual quiz, you can pause the video and you can think about it and decide your decisions. What is your answer? Then look at answer. So now we'll continue just go through the answer. So now you can see there's a wave propagate and there are 3 points. You have point A, B, C. So which one argument is true? So as you can see that because now it is the source which is moving, so apparently the wavelength between the source and the point C, the wavelength will become shortest or smallest. So therefore the frequency will be highest. So that is the reason that the observer C has the highest frequency. So now let me give you an example. So you have the train and traveling with whistles, and the whistles is approaching to the observer here. So let's look at the diagram, make sure you know all the conventions. You have a train produce a sound F frequency, and the speed of the train is u. And the observer here's a frequency f prime. So in the question A, they want you to find out f prime, which is the frequency heard by the observer. And in the question B, they want you to calculate that the sound from the reflected by the tunnel back to the engineer in the train. What kind of frequency does the engineer hear, which is the f prime here? So here we should deal with this one very carefully. You have three frequencies. F is the original frequency produced. F prime is the one heard by the observer. And F double prime is the frequency reflected by the tunnel back to the engineer. So there are three kinds of frequency. So let's see how to solve the problem. So for F prime, so in the case for the F prime, it is the source which is moving, but observer is fixed, and it is approaching. So therefore, this is a formula we should use with a negative sign here. And since the velocity of the train was given, and we know that how fast the sound wave propagates in the air. So that's the reason we put the 343 here. So in the case, you can calculate the frequency measured by the observer. However, for the question B, F double prime, it is the source which is stationary, but observer is approaching. So please make sure you understand what I'm talking about. So when we try to calculate f prime, it is the scenario that the sound wave was reflected by the tunnel back to the engineer. So this is the source now for problem B. And now it is fixed. So which means the observer is approaching. So therefore we should use the result we have in the previous lectures. So now f double prime is this format. And now because they're approaching, once again, you should use the plus sign here. So first, you have to make sure that which formula to use for each of the scenario. Then you have to decide the plus or the plus and negative sign. So this is not a hard questions, but I hope you can pay particular attention to how to use the two formulas appropriately. Then now let me have the brief summary. So the Doppler effect we just discussed, there is always one fixed, but in fact, both the observer and the source can move. So in that case, the most general formula for the Doppler effect is this is the f prime due to the movement of the source and observer. So if you combine these two together, even those in the future, in the questions, both of them are moving, you know that which formula to use. And now also the convention of the plus and negative sign is still consistent with our previous discussion. So don't get confused. The plus and negative sign in the numerator and in the denominator is still based on it is approaching or moving away from each other.